All right, everybody, we're back in part 3 now in chapter 12, non-renewable energy resources. And today we're talking and going into specifics on fossil fuels. We'll talk about coal, petroleum, natural gas, as well as some other kinds of fossil fuels. And by the end of today, your objective is you'll be able to discuss the uses and consequences of using coal, oil, and natural gas. Nuclear fuels, we won't talk about those in this part. Nuclear fuels is part 5. So first, just talking about what is coal. Coal is a solid fossil fuel formed primarily from the remains of trees, ferns, and other plant materials that were preserved between 280 and 360 million years ago. And there are 4 main types of coal, and they're ranked from in order from lesser to greater age, exposure to pressure, as well as energy content. And those 4 kinds of coal are called lignite, subbituminous, bituminous, and anthracite. And we'll take a look at the formation of each of these kinds of coal on the next slide. And we should also make sure that we know that the largest coal reserves in order are right here in the United States. Then next is Russia, then China, and then India. So the U.S. actually has the largest coal reserves in the world. Estimates indicate we have roughly 200 years worth of coal reserves at current usage levels. So as I said, let's talk really briefly about how coal is formed. Millions of years ago, we had our ancient forests that covered the Earth's surface, and when all that vegetation died, it went back down into the ground, and instead of fully decomposing with when oxygen would be plentiful, there were anaerobic conditions, which means that oxygen was very limited or non-existent at all, and so the vegetation was only partially decomposed. And so that created what's called peat, and that was kind of it's a fuel that human ancestors have used for heat and for cooking for a very long time. Some developing countries still do. And so that when you take that peat and you compress it between sediment layers down in the ground, which is what this diagram here is showing with these arrows pushing down here, and then over here the arrows are pushing up. So the peat's being compressed between the sediment layers. That's when you're going to form your lignite. If you further compress, so even more pressure and even more time, you're going to get your subbituminous and bituminous coal. That's this picture here. And then, again, even more time and even more pressure, you'll eventually form your anthracite, which is over here. This chart does a really nice job of going through the advantages and disadvantages of coal. They are very important, and we should definitely be able to go through these. First of all, start talking about advantages. Excuse me. Coal is very energy dense. So there's a lot of energy that's stored in the bonds of coal, and it's also plentiful, as I just talked about. It's very easy to surface mine, to extract from the earth, and we did talk about that back in chapter 8 with mineral extraction. And it's very easy to transport and easy to handle, and doesn't need much in terms of refining. So it's pretty much mined out of the ground, and it's transported to power plants via trucks or trains, and then it's burned right then and there, and that's it. Now, disadvantages, though, over on the other side, coal is probably one of the dirtiest fossil fuels. It has a lot of impurities, and those impurities are released into the air when they're combusted. All those impurities can be chemicals like mercury, lead, arsenic. There's also a lot of sulfur dioxide that's released into the atmosphere. Sulfur dioxide is one of the components or key causers of acid rain, which we'll discuss in chapter 14 with water pollution. So big problems when coal is burned. And when coal is burned, ash is left behind. So sometimes those pollutants are not released into the atmosphere. They're left behind in the remains in the ash. And so that ash is going to be fairly highly concentrated with all of those toxic metals that I just talked about. And the next slide, we'll take a look at coal ash spill. But the last thing to talk about here is, again, just like we discussed in the last unit with climate change, burning the coal contributes to carbon in the atmosphere, big cause of climate change. This picture here shows a coal ash spill in Tennessee from 2008. There was a coal burning power plant that collected the ash that was left over from the combustion, and it was stored on site. With some heavy rains, that ash mixed with the water, and the storage dam broke, and this released pretty much an avalanche of coal ash, and that destroyed this house. So big problem down there. Moving on to petroleum. Petroleum is our second kind of fossil fuel. And petroleum is a mixture of hydrocarbons, water, and sulfur that occurs in underground deposits. And what's really, really convenient about petroleum is that it makes it very easy to use for transportation in vehicles with oil and gasoline. And petroleum is formed from the remains of ocean-dwelling phytoplankton that died between 50 and 150 million years ago. Countries with the most petroleum: Saudi Arabia, Russia, the US, Iran, China, Canada, and Mexico, in that order. And it's from petroleum that we can go through a process called fractional distillation, and we can kind of filter and refine petroleum and crude oil into the different kind of fuels that we know about: gasoline, diesel, kerosene, asphalt and tar, etc. Okay, so again, that process is called fractional distillation. This picture here shows us a cross section of an oil drill going down into the ground, where there's a reservoir, and we can see that we've got our oil there that's trapped between two impermeable rock layers. That would be the shale here. And then we can also see that natural gas does tend to dwell at the surface of the oil reserve, and that can be harvested. That also sometimes can be burned. So you might see a small controlled flame coming from a drilling place. That's because they want to make sure that they're slowly burning it off, in terms of they don't want a huge explosion to happen. So advantages, disadvantages of petroleum. Advantages, just like we said, very convenient for transportation and easy to use, and again, relatively energy dense. And petroleum does burn a lot cleaner than coal, but there are still amounts of sulfur, mercury, lead, and arsenic into the atmosphere. Disadvantages: carbon dioxide, of course, and the possibility of leaks when transported and extracted. Now we'll talk about oil, big oil spills in a second, but there actually is some research that's being done that the greatest contributor to oil leaks is actually boats and small little oil leaks here and there, and all those small little oil leaks do add up. Although when you have a huge catastrophe, a huge oil spill, then that can also be a problem. This is a picture of the BP oil spill that I'm sure you've heard about from the Gulf of Mexico in 2009. You might have also heard of the Exxon Valdez. That was an oil tanker accident in 1989, which the tanker was about 50 miles off the coast. I'm sorry, that's a different statistic. But the Exxon Valdez, that was an accident that happened in the Arctic Ocean up there, and it was the BP oil spill that happened about 50 miles off the coast of Louisiana that spilled about 206 million gallons of oil into the Gulf. So big problem. The other thing to talk about is the Arctic National Wildlife Refuge, and this is a picture here. And so we can see that this was the Trans-Alaskan Pipeline that was built, and it was built to transport the petroleum that's being harvested. There were pretty big concerns about disruption of habitat for Arctic species like the caribou, who are pictured up here. There's current research right now that's being done into the 1002 area, which is this area in orange that's part of the Arctic National Wildlife Refuge. And they're looking into tapping into petroleum reserves up there to reduce the United States' dependency on foreign oil. And environmental scientists are very concerned about, of course, the impact to habitat and to ecosystems up there. And there's not really there's not really very conclusive evidence as to how this pipeline that was built has impacted the ecosystem up there. Last fossil fuel to talk about, or last main fossil fuel to talk about, is natural gas. It exists as a component of petroleum in the ground, as well as in gaseous deposits that are separate from petroleum. About 80 to 95% of natural gas is methane. About 5 to 20% is ethane, propane, and butane. And it does burn very clean. That's kind of, natural gas is kind of sometimes considered the cleaner or the greener fossil fuel. But as we'll take a look at on the second to next slide, there are some disadvantages. This is a picture here of a natural gas field in Wyoming. And this, like I was talking about earlier, sometimes you'll see a small flame coming up from any of these sites, which helps to control the natural gas that might be leaking from the extraction system to prevent a very large explosion. And so, again, this slide, advantages and disadvantages. So natural gas contains fewer impurities, therefore emits almost no sulfur dioxide or particulates, and emits only 60% as much carbon dioxide as coal. So again, it has been considered by some to be greener or cleaner, which it is. But even still, when methane's not burned, it could escape and enter the atmosphere, and we learned about the global warming potential of methane. And the exploration of natural gas has the potential of contaminating groundwater from fracking, which we will discuss in class. Really briefly, just want you to be aware of two other kinds of fossil fuels: oil sands and bitumen, tar pitch. So just take these down. We're not going to go into a lot of detail here. You may or may not see them on a potential quiz or test. But again, it's just fuels to be aware of. Oil sands are slow-flowing, viscous deposits of bitumen mixed with sand, water, and clay. And bitumen is a degraded type of petroleum that forms when petroleum migrates close to the surface, where bacteria can metabolize some of the light hydrocarbons and others evaporate. Last thing to talk about is coal-to-liquid technology that can convert solid coal into a liquid fuel. So CTL, coal to liquid. And advantages of this process here is that we've had this technology around for a while. It's been used since World War II, actually. And it definitely can reduce our dependency on foreign oil. As we said, the United States has the largest coal reserves in the world, so we've got plenty of coal. And so we can reduce our dependency on foreign oil if we are able to convert it to a liquid, which we learned that liquids are a much better fuel for transportation. Drawbacks, though, it's very expensive, and the EPA estimates that greenhouse gas emissions are more than twice from oil. So again, all those problems from burning coal that we've discussed on the earlier slides, those still exist with this process here. So that about wraps things up. We've got our 3 checkpoints. By now, we should be able to go back into our notes, and we should be able to answer the questions. How are the different types of coal formed? How is oil formed, and why does it need to be refined? And what are the major advantages and disadvantages of coal, oil, and natural gas? Go ahead and take some time, answer these in Edmodo. Again, don't forget that once you open up the Edmodo questions, the time starts, so make sure that you've got your answers prepared before you open up Edmodo. When you finish this part, you can move on to part